Well, welcome to this edition of the APSIM online seminar series. My name is Adam Liedloff and I'm an ecological and agricultural modeller with CSIRO in Darwin, Australia. In this presentation, I will discuss the crop livestock enterprise model, or Clem, that you may have noticed in APSIM Next Generation. So, why Clem? Well, researchers working with farmers and managers required a whole farm model to explore management decisions for small farms in emerging economy countries, as well as large grazing agribusinesses in Northern Australia. They needed to model using available data, which was often limited. They needed to integrate crops, pasture, livestock, and people. They needed to include the constraints of limited labour and limited finances on the system, and it also needed to include a wide range of management practices, as well as to be easy to use for a range of researchers. So, Clem. So based on these requirements, Clem runs on a monthly time step. It can use model output, field data, or expert opinion as input based on the available information. It includes an individual-based ruminant model with energy relations based on feed quality and quantity. It aims to be highly customizable through a plug-and-play approach to build simulations. It uses the APSIM tree structure for that in the user interface, and therefore doesn't require coding skills for most users. It includes a range of tools to explore the outcomes of the model for full transparency of what's going on behind the scenes. It also allows the shortfalls in finances and labour to influence model outcomes. It has full parameter validation, and the design of the model means that we've been able to add further functionality as needed by research projects, such as tracking human energy consumption, adding attributes to individuals, allowing us to start modelling management decisions based on generic merit, and creating a marketplace in which we can share resources coming from individual farms. So, where is Clem? Well, Clem is a standalone model provided in the APSIM Next Generation software. It's conceptually and operationally quite different to APSIM, as we'll see as we go through this presentation. So, probably the best way to quickly give an overview of Clem, which is growing to be quite a complicated and complex area, as you would expect when you try and model a whole farm. We'll look at the two examples that are provided with APSIM Next Generation. So if you're not familiar with the examples, they can be opened from the main home menu tab in the Open Examples, or you can find them in your APSIM installation directory under Examples/Clem. So, two examples come with APSIM at present, a cropping example and a grazing example. So, we will change across. So, if we open up APSIM Next Generation, here I have my previously opened projects, and we can see we have the cropping and grazing examples. So if we look at the cropping example, we see that it's a classic APSIM simulation tree on the side, with simulations, a data store, and a simulation which we call cropping examples. that's the simulation, sorry. Under that, we have two simulations set up, a single and mixed cropping system, and an example to show how to implement rotation cropping. So the single cropping system has a clock and a summary file, as we would expect, and then we get a Clem component, which holds all the functionality needed to run a Clem simulation. Under this, we have data inputs, so where the model is going to get the information for the simulation. And in this example, it's coming from two output files that were previously generated in APSIM with some maize and vegetable production. Clem is primarily a resource accounting model. That means that a farming system is effectively a group of resources with which you can perform activities to create or use those resources. And we have to actually start thinking in this approach to fully understand and work with Clem. Therefore, we have to start to consider the concept of arbitration of resources. What happens when two conflicting activities or tasks require a resource that's actually limiting? We found that the simplest way to allow the user to control arbitration was to use the order the activities appear in the tree structure, or the order the resources appear in the tree structure. And for this reason, and we'll see later on, the tree structure in APSIM Next Generation actually becomes a fundamental part of the Clem simulation. So if we look at our resources holder, we see that underneath we have, in this simulation, 4 different resource types that we can start using. Land is a resource. Activities can request land, do things with it, and give it back if they want. Land could be sold, land could be purchased. All this is possible. Most of the resources, I should say, follow the same simple rules. We're used to resources such as finances, where we have money coming in and money going out of a bank account with a classic ledger or bank transaction report. That's the resource that we understand, but all resources are effectively similar. So land, likewise, could have a transaction report as land is taken from the store, used, and given back. Likewise, in this simulation, we also have labour as a resource, and we have a product store, a place where we can store products as they're generated, and then we can do what we need to do with them. So underneath our land resource, these are the resource groups, and they hold individual resource items. So we have a single field. Whenever you click a component in Clem, you'll get a description of the component, any of the properties associated with the component, as well as some summary and version information, which we'll get to later. But this example shows that we have a land area of 2, nothing taken up by buildings, and we've given that a land index or a land value of 4, which we use in lookup tables and databases. So this value of 2 at this point doesn't actually have any units associated with it, but if we go back up to the land resources, we can see that this model is working with hectares, and we need a conversion factor to bring it back to our standard hectares, which in this case is 1. But you could be working with whatever the land measure is in the country, for example, you're working with. Next, we have some finances. In this case, we just have a single general bank account with an opening balance, calculations of interest rates, and whether or not we enforce spending limits on that account. We also have some people on this farm. So we have a 42-year-old male, one individual, and we have a 35-year-old female. A range of other details is also required when we're setting up different parts of the model, and by nature they are located where they're most logically needed. So in this case, under our labour, we also have what's called a labour availability list, and this is the set of rules that define how much time the various people in the household or on the farm have to perform labour. And we'll go into more detail into some of these various parts of the model in future videos, or you can go and look at the quite comprehensive reference guide and user manual, which is online and at the address above my head. We also have a product store in this simulation, and you can see that we're able to receive things such as maize, tomatoes, tomato paste, and cucumbers in this run. The maize is measured in kilograms and has no starting amount at the start of the simulation, but we can see there's also a component below this, and that is a pricing component. In this case, we sell maize by the tonne, and it has a nominal value of $200 per tonne. These simulations are totally fictitious in terms of the numbers and things provided, but they're just meant to give you an idea of how to set it up and what you would expect. This price is also a sale price. You are able to specify prices for purchasing, sale, or both in the same price. So you can actually have different purchase and sale prices for resources. So now we've sort of got an understanding that we've got our land, we've got some money in a bank, we've got some people to do tasks, and we've got somewhere to store our resources. We need to start to think about how we would manage this farm. This is performed by what we call activities. So activities are the various tasks performed on the farm. The sort of object-orientated approach of the model means that activities generally do one thing, and you might need multiple different activities to perform different aspects on the farming system. So let's quickly just run through what we've got here. We have an activity called Manage Maize. This activity needs a land type. So this is the first place where an activity is going to request some land from the system. And you could imagine an activity later on requesting land. There may be no land remaining, therefore we have constraints on the model. So it's needing land from the land type called field, which we saw previously. We have a category for transactions. This just allows you to start to provide a custom ability to filter and work with your output results. So all transactions associated with this are going to be called crop. We've got a whole range of other things that apply to a range, just about all the activities. And one of them is, what does this activity do when there are insufficient resources to perform the activity? There's a range of options here. We can report an error and stop, suggesting that this is a critical case that we shouldn't ever run out of this resource. We can simply skip the activity. So if there's no money left in the bank, we won't bother even trying to do this activity in this time step. Or we can use the resources available. So if the activity has the ability to adjust and work out what it can do with the resources available, it will continue. We're asking for 1 hectare of this crop, and that is what sets up the crop. Below that, so that's setting up the crop. A crop can have a whole range of products. The classic one is for our maize crop. We actually have maize grain as the product. Now, this is where we need to start linking Clem with the various input files. In future, we certainly plan to actually have Clem dynamically running alongside APSIM crop and pasture models so that we can interact between the farm model and the crop and pasture models. But in this case, we can see that we require the file crop maize input file, and we're looking for a crop in that file column called maize sol fertilized, and we're going to store that in the product store maize. And when you start clicking various of these drop-down lists, they know what options are available. So in this run, a crop can only be stored in one of the product stores, and in this case, we've selected the maize store, and we're going to harvest 100% or all of the crop that comes in. Then we see that under that, we have another component, and this is a labour requirement component. So most activities can also have various requirements. They could be labour, they could perform the task on particular individuals, and so they need to be defined here as well. So in this case, we have this activity requires 5 days labour per unit, and we're using per hectare in this example, and a person can work for a minimum of 1 day and maximum of 100 days, and we're allowing labour shortfalls to influence the crop outcomes. This really only just says, the amount of labour required. The model requires more information, and that is who in our labour can perform this task. So under here, we have what's called a labour filter group with a labour filter under it. So if we look at the labour filter group, it doesn't have any properties, but when we look at the labour filter underneath, we can see that it has a rule-based system, and we can have as many of these filters as we like. So it's basically saying for the labour, sex must be male, or sex equals male is true, or the operator could also be equals sex equals male. And so we have a whole range of different properties depending on who is being selected. And we'll get to better examples of that when we move into the ruminant system. So we can also do things with maize. So in this case, we have a sell activity. So we're using the general account in our finance system. We're going to tag it with sales. We're selling anything that's in the product store.maize. And the selling style is that we're going to sell a proportion of what's available. In this case, it's all of it. So every month we will try and sell the maize in the store. And that leads us to timing, which I'm not sure we have any timing in this model, but we'll certainly explain that likewise in the ruminant model. Without timing, every activity is expected to run on a single every month, and there's various tools which we'll get to which show when activities were performed and whether they were performed successfully. We also have some vegetables to manage. It follows the very similar layout that we used before. So we're setting aside 0.2 hectares for growing vegetables. We've got some tomatoes being grown, coming in from the file crop vegetables reader, and they're in the column named tomatoes. And we're actually only harvesting 0.8%, 80% of the harvest to indicate that they're growing alongside the cucumbers, and there's a slight reduction in production. There's a labour requirement for this, and this time we have some females in the labour, so sex equals female, and if there's insufficient females to produce the labour needed to grow the tomatoes, we fall to the next labour filter here, which is sex equals male. So any available male labour will be provided to do the remaining harvesting of tomatoes. Next, we have that we're also growing some cucumbers, and likewise there's a labour requirement below that. On this farm, we want to do some value adding to our crops. So we're going to actually produce some tomato paste and sell that. So we have a folder here, which basically lets us lump some of our related activities together. And we can see that we have an activity called Make Tomato Paste. And this is a resource activity process. It has properties such as the resource to process, once again, our transaction category name, the resource created, as well as the rate of conversion. So this will convert 1 kilogram of tomatoes coming in into 100 grams of tomato paste. This activity has some other things associated with it. It has a labour requirement. Once again, the female part of the labour as well as the males can perform this activity. We also have what's called a resource activity fee. So this is an expense needed to perform this activity. In this, we need 20 cents per kilogram of tomatoes processed that goes towards buying jars to put our tomato paste in. And so basically, as tomatoes become available in the system every month, I will say that the flow of the tree is important, but Clem also has a whole range of events firing in a particular order off the clock. So that just makes sure that pasture production happens before the animals try to eat it. We have all the intake and energy calculated before milk production, etc. So in this case, if there is tomatoes in the store in this month, they will be converted into tomato paste. And finally, we have another sell component similar to our selling maize, but this time we are selling tomato paste from the store whenever it's available. And this activity also has an activity timer, which says only perform this activity in November. So it's going to first perform it in November and then every 12 months. So every November, we will sell our stock of tomato paste that may have been generated throughout the year. We have a series of reports. All the Clem components have their particular Clem icons associated with them in the colour scheme of teal for activities and the brown colour for resources. So if we look at some of the activities, we have a report activities performed report. The few properties associated with it. What this does is it tells us on every time step during the simulation the status of the activity. So here we can see that we have the grow maize crop activity. It happens. Whereas if we look at the sell tomato paste, we can see that the little dot means the activity didn't even try to happen, and that's because this one is being run by the sell in November timer. When it happens, we got a green check mark, which meant that something was performed and everything that needed to be performed happened. Likewise, our grow maize crop, we can look through here and we can see when the maize is coming into our system from the input file, and we can see that it seems to come in May, and then March and April. So we can actually sort of see things happening. We can see the tomatoes coming into the system. Here we can see May and June was tomato production. May and June also had some tomato paste production. And then we sold the tomato paste in November. Likewise, there's a report that just starts to show you where labour is provided in the simulation. So we can see that to grow a maize crop, we basically needed male labour. As I mentioned before, we have finance ledgers, which are fairly typical of what you would expect from a finance ledger. This one has a gain and loss column. There's options in the previous screen where we can say use gain loss columns or use a style of transaction and amount, which would be the column values would be gain or loss and the amount. But the run we've done has a gain and loss column, so we can basically see that $100 appeared at the start of the simulation, and if we move across, we can see our category value that we were talking about before. We have an opening balance. We can see all the sales and the processing of tomato paste, so we can start to show this in results and graphs. Likewise, we have a labour ledger, which is very similar to our finance ledger, except now we're looking at days of labour for the various activities. And so be like scrolling while I'm sharing for some reason. Yeah, there's also the category at the end of that. We have a resource balances where you can start to specify, give me the current value of a resource at a given time. And in case I needed to clear the data store, but we can see that the general account, we can see the starting value, and then we can start to see income coming in through time. There's also a useful report which shows wherever you've had resource shortfalls, just to give you an indication of where the system has been constrained. In this case, we don't actually have any resource shortfall, so the model ran well. The difference between that and the rotation crop example is we will just look in the activities. In this time we have a crop using pad 1, which is the name of the land type in this one, and it's looking at 80 hectares, and we this time have two different products in the simulation. We have a wheat, so we set up the wheat, and they're all coming from the file crop reader. There's a column called wheat being stored in the product store called wheat, and we're harvesting all of it. And we also have sorghum. Now, the fact that wheat and sorghum are in the list above and below each other means that this model will harvest the wheat, and then it will stop with wheat and wait through the input file until it gets a harvest of sorghum, which gives us our rotation cropping. If the sorghum had have been nested under the wheat, we would have actually had both crops coming in whenever they show up in the system, like our tomatoes and cucumbers, which were grown in a mixed cropping system. And we have some activities to sell the sorghum and wheat. So that provides a very simple cropping system. And if we have a quick look at a grazing system, we'll see probably some of the most detailed parts of the Clem simulation. We find that we have a new random number generator that's needed to provide the stochastic numbering across Clem. Clem uses an individual-based ruminant model rather than a deterministic cohort-based model. This has a number of advantages, also some disadvantages, but it means we move into a stochastic model where the death of an individual based on a probability of mortality ends up being a stochastic outcome, effectively coin toss. And this is where we set up just how that random number generator works. And we'll note that that's outside of Clem, so that random number generator can be used across multiple farms in a simulation. So inside Clem this time, we have a forage file, which is set up to provide the primary production of the pasture. We have some resources. This time we still have our land and our bank account, finances. We have an animal food store, so similar to the product store. We have an animal food store, which I sort of think of as the barn, and in that we are storing hay. And this hay has an interesting component under it. This is what we call a transmutation. So a transmutation effectively converts one resource into the shortfall resource when demanded. So in this case, we have our shortfall resource is the hay, and we work with units of 1 tonne of the hay, and we need to decide which resource we're going to convert. So we will transmute the general bank account, and 100 units or $100 will be converted into hay whenever hay is needed. So there is the option of providing this sort of functionality through activities in the model, where you might say have a purchase hay activity, which purchases hay on a particular month based on some other conditions. But this transmutation will automatically fire whenever the resource is in shortfall. And we'll probably see some examples of that kicking in the outputs. We have the graze food store. This is different. This is actually our pasture. So in this simulation, we have one pasture type called the native pasture. And here we can see some of our components have quite a number of properties. We've got here a categorized property presenter, so we can actually start to look at just the basic properties, which are those that most users should be able to find the values of, as opposed to the advanced properties, which sometimes require more expert involvement and probably shouldn't be touched by sort of entry users. So here we need to start to describe the pasture. Clem uses sort of a hybrid approach where we aren't linked to a pasture model directly. Working with tropical pastures across northern Australia has always been somewhat difficult, so we look to some field measurements for modelled output of the monthly primary production, so the green growth in any month. And with that, we set its nitrogen, its dry matter digestibility, and then we have a range of very simple detachment and decomposition rates. So we say how quickly each month that new growth detaches from the system and is lost. We also have the rate that it decays in its nitrogen content and its dry matter digestibility down to a minimum value. So therefore, through time, we can follow that pool of pasture such that when the animals come to graze, we have a range of pasture pools of various quality, various quantity that the animals select from for their consumption. We've got some initial biomass calculations here and some sort of smarts behind it to define and set that initial biomass based on the starting month and when your grass production is likely to happen. As we've seen before, most of the resources have very few properties associated with them. Most of the properties come from down in the activities, which is where the values are being set. But this is a case where we need to describe the pasture where it's defined. We also have ruminants. So this is our herd of animals in the farm. And we have a ruminant type called Bos indicus in this simulation. This is one of the large property sets. So basically here we define what makes a Bos indicus and how that's different to a sheep. So there's a huge range of values here from the previous research and scientific literature behind the model. Once again, we have some basic parameters, so we can look at general parameters such as standard reference weight and animal equivalents. We've got growth, diet, survival, base mortality rates, lactation and breeding values. And underneath the advanced, we have the more detailed parts of the various equations needed to define the animal. We also have some components underneath the ruminant type, and here we have a list of initial cohorts. Underneath those is each cohort. So here we have 8-month-old females. There's 2 of them, and they weigh 180 kilograms. We can provide a standard deviation to that weight, which will produce a normal distribution of weight at setup of the model. We can also set weight to be 0, and the model will use the normalized weight as defined for that breed. So here we can see there's a range of initial cohorts with some weaners, some females, some males. We also have prices. This is basically a pricing list. So this basically lets you build your pricing structure. So the model, whenever it comes to check the price of an individual, will work its way down this list until it finds a price for that animal. So you can have catch-all values at the end of this list, or this list may just be one single value where every individual in the herd is X dollars per kilogram of live weight. But here we can see that we have what's called weaners, less than 12 months old, and they're valued at $2.50 per kilogram of live weight. There's a whole lot of pricing we can do per head, per adult equivalent. And this is both a purchase and a sale price. That's fine, but that hasn't currently defined the individual. So we move, whenever we need to define the individuals upon which to work, we move to filtering. And in this case, we have a filter where the age of the individual is less than 12 months. And so we'll see that as we come down, for example, the males 1 to 3, we have sex equals male and age less than 36 months. So this is where we've now defined all our pricing for this simulation. And we also have a ruminant conception curve in this run where we're using a curve to define the conception rate each time we breed. So we've effectively now defined our resources, and we need to look at our activities. We have native pasture on the farm. Much like our cropping, there's a couple ways to do pasture. This is the simple approach, which basically uses our input file, exactly the same way we did cropping previously. So we're going to use paddock 1 from the land resources, and we're going to grab 100 hectares to grow these animals on. From that, we want to grab the native column and store that in the native pasture pool of the graze food store. So that will handle our pasture through time. And now we have a whole series of activities that are needed to manage the animals on this particular farm. And we have all of these grouped under an activity folder that we've called Manage Herd. So one that we always need, we need a grow all ruminants. This activity handles all the energy relation, growth, and mortality of the animals in the herd. We have an activity called Ruminant Activity Move. Basically allows us to move animals around the farm, and we do that by selecting the location, in this case, effectively putting them on the graze food store native pasture. So we're putting them on the native pasture, and we're moving them at the start of the simulation. So the animals are on pasture when our model runs. This has a filter group under it because we need to know who we're filtering. It's a select as opposed to a destock filter group, and it has no filter items under it, so it will basically filter all individuals. We then have a graze activity with a few settings that just basically has all the functionality to do the grazing. So it will work out the animals moving, what feed is available, and feed the animals. We have an activity which is a ruminant activity feed activity, where we're going to actually feed the animals from the hay store, and we're feeding them a proportion of their remaining intake required. So there's actually some options in the model that make you a super smart farmer, because the model knows things that you may not know, such as how much the animals still need to eat. But this is effectively the same as saying, let's let the animals feed up to when they're satisfied. And we need to specify once again the group of animals. This time it's all of them again, and we're going to feed them the whole proportion of the remaining intake required. We have a breeding activity, and under this breeding activity, if that's just on its own, it will do uncontrolled natural mating that only happens when males and females are in the same paddock together of breeding condition. So you can actually manage your whole farm by moving animals around to undertake your breeding in various paddocks. But in this case, we're going to use a controlled mating component, which starts to let us define maximum age of females that we're going to consider. The number of joinings per male is needed when we start looking at genetics. So in this case, every mating will be effectively a different male, and we're going to perform the controlled mating every March. We have a weaning activity. In this case, it's an age or weight-based rule. So we're going to wean animals at 8 months or 100 kilograms, and we're going to move the weaners into the native pasture. And that happens every April. We also have a managed numbers activity. This is probably one of the biggest activities because it performs a whole lot of tasks. Most of these tasks can now sort of be turned off, and you can manage them independently in other activities if you want to. The model works with the number of breeders in the herd and is always trying to maintain the number of breeders between set values based on purchases or from within the herd. There's a range of destocking and restocking rules. You can have a grow-out herd with castrated males, a separate or the same paddock, those animals will grow out to a given age or weight, and then they'll be sold. We can have it perform some adjustment of your initial herd structure up to your set stocking rates at the start of the run. This one's performed every August. This one actually requires a few different components that you'll see here. We have a breeder's component that specifies the age of breeders when they're purchased, and we also have likewise one for sires. So when the model needs to get details of the animals purchased, it looks at these two. We have a buy and sell activity that is managing the purchase and sales of the animals. This can have an activity added underneath it, such that if we add a model and look in our Clem components, we're looking at activities. Here's all the activities we can use. We can actually add some trucking settings to this, which lets us set up emissions, truckloads, all sorts of trucking rules, if we want to constrain our purchases and sales by trucking rules. So the idea is that you add complexity to the model by adding more and more components. So some of those that we've seen is like controlled mating. Leave that out and the system defaults to natural mating. Leave trucking settings out, the system defaults to just buying and selling based on funds. If you have no finance in the model, the buy and sell activity has no constraints and will just do its purchases and sales. We can add greenhouse gas resources. If they're there, greenhouse gases just start getting calculated through the ruminant growth model. Will give us our our methane emissions, likewise the trucks. So there is no assumption. The idea is that you use the most limited amount of properties required to perform your simulation. So you're not throwing a horrendous model with every option possible to use. And we will have a quick look at some reports. So this time our activities performed report will be a little bit more detailed, because we can see we've got a range of different timers running through the model. We can see here that the controlled mating is happening, weaning is happening, managed numbers. So here we can see that managed numbers tried to happen. What is that? That might be weaning. Yeah, there's a slight offset issue here that I need to correct. Yeah, so that's a good way to look through your whole simulation and see when and where things are happening. There's a whole range of other icons that will appear, such as exclamation marks, a little pie symbol that says, yes, I did the activity, but I didn't have all the resources needed. A whole range of things there. Some activities, such as your cropping activities and the tasks associated. So maybe the data input didn't allow you to have 5 months before your wheat harvest, so you weren't able to do a prepare field in the first instance in the model. All those things get provided. If we look at the herd ledger, this is effectively our bank transaction, for the herd. So effectively, we have every individual coming or leaving the population. So here we can see under the category column the initial herd. This is the animals being added when the model started up. Under that, there's 3 age weight sales. One of them was a breeder, 2 of them were pre-breeders. You can go and find the definitions of these classes. It tells you what type within the herd it relates to. We only have Bos indicus, and there's a change value which determines whether it was a input or output from the model. But we can also see here's some calves being born, some age weight sales of weaners. So there's a diet of mortality of a sire. So you can actually use this to follow and get some really detailed idea of what's happening to your herd. Each individual, as it comes and goes, also has a whole range of information associated with it that you can also add any property of the individual. So we know its age, its weight, adult equivalent. So we could therefore look at what is the average weight of individuals dying during our simulation, or per month, or whatever you want to look at. The other thing is, as you could imagine, there's a fair bit going on behind the scenes here, and how and where you have filters and filter groups and timers and nested versus non-nested objects actually dictates a lot of what's going on, and it can quickly get quite confusing. What we have in Clem, if we click on Clem, we have the messages is what we see at the bottom window of the simulation when we run it. So this simulation ran last time it was performed. This is where Clem will also report all the error messages. A lot of the errors that happen in Clem will give you some instructions about how to fix it. There's also a whole lot of warnings that can appear here. So where Clem thinks you may have missed something or something a little odd happened, it will often give you a warning here just so that you're aware that something went on that you don't think probably should have. But the other thing is the model doesn't assume anything. Some of the models in the past that our users were using had rules like if conception drops below X, stop the model, and that's not very useful for trying to look at some of the outcomes of management where you may actually want to degrade a landscape or let the population crash to zero and things like that. Right, so the other thing I was about to say is that there's also, in the summary section, you can head off to viewing the descriptive summary, and you can also go straight to the help system and look at the help on the component that's currently selected. So if by selecting this component, it's automatically generated the descriptive summary. So if we go to our browser, make sure it's refreshed. That's looking good. Go to our browser. So we can see that we've generated a descriptive summary of the whole Clem simulation. So, yep. So here we can see all the values that are set with a description. So you effectively should be able to read through this document. Here we can see the setup of the forage. Here we can see that land is reported in hectares and the land type 250 hectares with an identification of 2. We can see that we haven't specified a currency. We've got interest rates happening. Here's our initial cohorts and our prices, our conception rates. Here's our native pasture description. Moving down into our activities, we can see that native pasture on the farm uses the unallocated proportion of paddock 1. This product is placed in the native pasture store, and data is retrieved from file forage using the crop named native. So everything that you've set up is described, including which animals. Controlled mating is performed every 12 months from March. And so a read through this, anything that doesn't make sense suggests you may have a setting wrong. It also highlights where things haven't been set. So because we dragged a trucking settings in, we can see that there's no kilometres to market, there's no cost per kilometre per truck, and we haven't set truckloads. So if we try to run the model, it also has full parameter checking. So we would expect that we would get some errors if we try and run this grazing model. Yep. So we get an APSIM error down the bottom, which we can look for more information, or we can click on the Clem component and go to our messages. And here we see that we have an invalid parameter in the trucking settings. The number of 450 kilogram per truck, the value of 0 must be greater than 0. So we actually have an error in the model, and that gives you an idea of where to go. This is the full description of where that component is in the tree structure. And so therefore the model won't let you continue until you have fixed up that problem. So, yeah, there's a range of other report types. We've got some pivot table reports as well as SQL-like reports where you can actually pass a SQL query to the database and it will create a view in the database that you can then use to graph that. Our preferred approach coming up is that we're going to start doing a lot of our analysis of the models in things like Microsoft Excel with Power Queries and Power Pivots linked directly to the SQL-like database that APSIM's producing. So run the model, update the data, and we can let the users work with pivot tables and things in Excel that they're very familiar with to work on potentially very large data sets that an Excel spreadsheet wouldn't let them work with, and we don't have to develop all that infrastructure in the user interface of APSIM next generation. So that is a very quick run through of a couple examples of Clem. As I said, there's a whole range of activities already developed that can be dragged into the interface, have their properties set, and you can use. So there's a huge range of farming systems that you can actually already work with. We're looking at adding more in future, more resources. You could imagine if we had the farm equipment resource, we could track farm equipment with its life cycle, purchase cost, depreciation, servicing intervals. The model could be tracking when it's used, hours of use, and therefore if you don't have the labour to perform your servicing, then that piece of equipment starts to have a higher and higher likelihood of breakdown, which will potentially affect the farming system later on when you don't have access to a harvester or a tractor or a bore pump. So we have a clem@csiro.au email address. I recommend you go and have a look at the help system. Very interested to talk with the rest of the APSIM Next Generation community about how we better combine various models. Because Clem runs off the APSIM clock, we can actually have models running together, and we've started to do some projects looking in this space. So we welcome any feedback or questions you might have, and yeah, we just hope you have an explore and hope you enjoy Clem and find some really great research projects to use this model with. So thanks for your time, and we hope to have some more examples in the near future. Thanks a lot.